Alright, so this video focuses on homework 6.1 question number 5. Okay, and they ask you to use integration by parts to find the antiderivative of 5x divided by e to the x dx. Okay, and once again the formula for integration by parts is uv minus the antiderivative of v du. So we have to select a u, and we have to select a dv. Okay? And for u, you're going to choose something that's very easy to differentiate rather. So we're going to choose 5x. And for dv, that means we have to be left with e to the x, 1 divided by e to the x to be precise. So du is going to be 5 dx. And we can rewrite dv as e to the opposite x, so it's much easier to anti-differentiate. And by the way, there should be a couple of dx's here to account for the fact that it's a derivative. Okay, anyways, we can do that simply by our properties of exponents. We can flip that into the numerator and just make it an opposite sign. So then, when we anti-differentiate that, we'll end up with opposite e, opposite x as our antiderivative. And as usual, we'll just plug back into the integration by parts formula, which will give us 5x, opposite 5x, e to the opposite x. Sorry, don't know what I'm thinking today. That's e to the x. And we're going to subtract v times du. So I'm going to leave that 5 outside. And then I'm also going to absorb the negative outside as well. So it's going to be plus 5 e to the opposite x dx. Right? And we already anti-differentiated e to the opposite x. And we got opposite e to the opposite x. So what we get is 5 opposite 5x e to the opposite x minus 5 e to the opposite x plus a constant. And that's our answer. So to recap really quickly, all we did was choose a couple of the functions and set them up for our integration by parts. We rewrote our dv so that it was easier to anti-differentiate. We anti-differentiated, plugged back into the formula, and came out with opposite 5x e to the opposite x plus c. So if you have any more questions regarding this problem, feel free to post a reply. Have a good day.